All right, here's our video, The Speed of Dark. And there's a lot of confusion on this. And I've been hearing students talk about it in the halls. I've been hearing it on campus. There is no speed of dark. We need to get that straight right away. Dark is not an entity. It's nothing. It has no energy. All it is the absence of light. So very important to write that down. Dark is just the absence of light. Let's write it. My pen, where's my pen? The absence of light. Light is absent from class. That's all dark is, the absence of light. See, light is an entity. Light has energy. Light has photons. The energy is the photons, right? But dark has no photons. When the photons go away, when they disappear, that's dark. That's all it is. You think of you. When you are there at school or wherever you are at work, you're there. When you leave work, you're not there. Think of a person like Bill. Here's Bill having a good time. Bill's at the party, and then Bill leaves the party. He's not there. There's Bill, and then there's not Bill. It's the same with dark. All right, so let's get our pen here going with yellow. Let's make a sun. Attempt to make a sun, right? Our yellow dwarf sun. And of course, what's leaving the sun in all directions are photons. These little package of quanta. And there are many in the superhighway of light, and they're going in all directions, but let's just have it go this direction toward Earth. We'll just have Earth over here. There's Earth. And it's bathed in photons every second. Guess how much? More than millions, billions, trillions, quadrillions, quintillions. It's 10 to the 45th power of photons. That's 10 with 45 zeros every second, every day, every hour. Keep going. It's been doing that for over, well, not over, but close to 5 billion years. Right? 4.6 billion years or so. So all these, and by the way, I'll write it over here, what it's called, the amount, quattro decillion, or decillion, whatever you want to spell it. It's an enormous amount. And these photons will take 8 minutes and 19 seconds to reach Earth, Gaia, unless something blocks the sun. So let's say, hypothetically, that there's some giant being blocks the sun. So when it blocks the sun, no more photons would leave the sun, and eventually, in 8 minutes and 19 seconds, the Earth would be dark. There'd be no light. And the darkness is not moving. It may appear to move from someone outside. So when that hand comes up, eventually all these photons, they're not disappearing, they're just moving. Dark is not moving, it's just dark was always there. Right? And it just seems like if like I said, some watcher, another Marvel comic reference, it would seem like there's a movement of dark, but dark is not moving. It's just, again, the absence of photons, and eventually we wouldn't be able to see Earth anymore. So dark doesn't have a speed. It's not an entity. So it's important to know that dark is not moving at all. It's just there with an absence of light. But another interesting concept, as you're seeing here, is shadows. We know shadows move. Well, they appear to move, right? And we've all done this. We've all made shadow puppets. I don't know how many people have made actually a puma on the wall or mountain lion. And we do know that shadows get bigger as we move away from the source of light. So if we had our flashlight, get our pen going over here. We have here's our flashlight, right? And as we move an object, whatever the object is, this ball or something, it'll create a shadow. As we move it away from the source, the shadow could get bigger. And we've played around with this. I'm sure we've all done this camping or in our bedrooms at night. And there's another thing that's going on. Here's a lot of misinformation about this. You see on some sites on YouTube where they're saying that a shadow could move faster than light, and that's absolutely false. And we'll look at that. We have to do some math. It's easy math, don't worry. And again, we all know that shadows could be much bigger than the object, again, depending on the light source that we're using. And so, one of the things that people have been trying to say is that shadows could move faster than light based on shining a light source on the moon, which is, again, improbable. But let's go along with that. This could never happen. It looks cute, but we can never do that. Okay, let's make sure we have some numbers already. So, the speed of light. So, we'll say light speed. Now, light speed is 186,000 miles per second. Extremely fast. You snap your fingers and light can go around the world 7.5 times. Go around the world. It's enormous, the speed that it can do. But I'm going to put it into inches because we're going to use inches in our equations. So that's 11,804,647,000 miles. Or I say inches, that is, inches per second. So in 1 second, light will go close to 12 billion inches. So we'll keep that in mind. Now the diameter of the moon, let's see we'll use yellow. That comes out, yeah. The diameter of the moon is 2,159 miles. There's the diameter of the moon. So let's say we took a flashlight and we were able to illuminate the moon, which we just couldn't do. So let's just, again, we're going to do that. We're going to have our flashlight. Say there's our flashlight. We'll put a flashlight in green. And it will illuminate the moon like we're seeing here. So we need a lens. So let's say that the lens is 2 inches. We'll just have a 2-inch lens. So if we take our finger, use purple for our finger, and we move across the lens, we just cut right through the lens with our finger, pretend that was our finger, and we created a shadow. We'll use the shadow in purple. Let's say we created a shadow, and we were able to move the shadow from 2,159 miles. What it appeared to be moving, we only moved it 2 inches with our finger, and yet it would move all across the diameter of the moon. So let's see what would happen. We also need to know the distance formula. The distance formula, right? We know that distance over time equals the rate. So we're trying to find the rate. So what we need to know is we already found the miles of the moon. We just need to find that in inches. We want to use inches because we're using inches for our flashlight. So 2,159 miles, if you convert that to distance in inches, it'll be this. I'll write that down. 136,638,240 inches. And let's say that we're going to take our finger and we're going to move it across a 2-inch lens. And we're going to do that in, let's say, half a second. So let's say half a second. Now, if we did this, we would get a rate. This will be our rate of what our finger is actually moving. $273,000,000 to 276,480 inches per second. Nowhere near light speed. So you can see And by the way, it's the improbability of having a flashlight that can illuminate the moon. Again, it defies the laws of physics. But let's go a little further. Let's clear that out. Let's say now that we're going to use a flashlight that has a 1-inch lens. The small, so we'll say 1-inch lens. Again, the smaller the lens, the faster we can move our finger across. And if we moved our finger across the lens, the 1-inch lens, let's say we did it in 5 milliseconds. 5 milliseconds is 0.005. That's extremely fast, first of all. And again, the likelihood of a 1-inch flashlight having enough power to illuminate the entire moon is, again, defying physics. But again, let's say here's what our finger is. Here's our finger, putting it in purple. And it's going to move across the moon. So again, we put it in inches. We said the moon was, we'll write this down again in inches. This is the diameter in inches, right? 136 million inches, 137 million inches to round it. So we're going to take those inches, 136,638,240 divided by 0.005. That's our, right? And we want to know what our rate is for our finger to move. Or, well, this case would be the shadow. And what you find here, as I write it down, is something that's faster than light. So this is what people have been saying on the internet. So your shadow could move faster than light. The math shows it. The only problem is the physical improbability of the technology. So we don't have it's just improbable to have a 1-inch lens illuminating the moon that much. But the math does work. So that's the thing about it. That's why there is some misinformation about that on the internet. But as you can see from the math, it could move faster than light. But according to the theory of relativity, nothing moves faster than light. So yes, our math is right. The only problem is defying the laws of physics with this flashlight. All right, so again, reviewing the speed of dark. There is no speed of dark. Dark is not an entity. Dark doesn't even move. It's just the absence of photons.